Hello everyone, I am Monika Bhushan and today we are starting lecture number 4 of numerical methods. Okay, so in today's class we are going to see Newton's backward interpolation. Okay, fine. Since in lecture number 3 we have discussed the concept of interpolation in details and there are different methods. We have discussed those all things in details. We had seen even a forward interpolation and today's class we are going to see the backward interpolation method. If you have not seen lecture number 3, I will suggest you to go through lecture number 3 before coming to Newton's backward interpolation. Okay, as we have said that Newton's backward or Newton's forward interpolation formula comes under interpolation for equal intervals. Fine, no? That means those type of questions where they have provided us the different instances of any independent variable. Suppose the independent variable is x and those instances are x0, x1, x2 and so on. So if those instances are equidistant, right, that means their interval is same. So we will be using either Newton's forward or backward interpolation formula. So fine, those things we have since discussed. So we are just concentrating on Newton's backward interpolation formula. Fine. So since we have discussed forward interpolation formula, so we will relate this formula that in Newton's backward interpolation formula with Newton's forward interpolation formula. So I hope that you have memorized Newton's forward interpolation formula. Then you just have to replace few entities in forward interpolation formula and then you are done with this formula, right? So what is Newton's backward interpolation formula? We are saying that this yr is what? So you are going to find the value of y at any given point. That point could be any real number. Fine. So that could be positive, negative, fractional, decimal, anything. Fine. In the formula, r represents all those real numbers. Okay. So yr is yn. Okay. Yn plus r into backward difference yn plus r plus 1 by factorial 2 backward difference 2yn plus so on till your last term which is ending with backward difference n yn. So this n again we will be discussing. Okay, so if we are going to relate forward and backward interpolation formula, so which all changes we are going to make? So we are going to replace y0 with yn. Okay, so this very first term what I am talking about. So y0 in my Newton's forward interpolation formula was what? It was your first entry under y column. Correct? No. But in your backward interpolation formula, you are going to take the last entry of your y column. Fine? Okay, so second change what you are going to make in your forward interpolation formula is what? There we used to write down this upside triangle to denote forward difference. Fine, no? In your backward interpolation formula, don't forget to write down this downside triangle. This represents backward difference. Fine? Okay, so third change what you have to make is, here you will see that my term is r plus 1. And again you are seeing r plus 1, r plus 2, right? That means in our Newton's forward interpolation formula, we used to deal with r minus 1, r minus 2 and so on. Here you are going to write down r plus 1, r plus 2 and so on. Fine, no? And if you have any doubt in this concept, why we are writing down r minus 1, r minus 2 in forward interpolation formula or r plus 1, r plus 2 here in backward interpolation formula. So these all things we have discussed in details in lecture number 2. Fine. So if you have any doubt, you can check those things in lecture number 2. Okay, fine. So that means these three changes if we are going to make, we are going to build the formula of Newton's backward interpolation. Fine. Now we'll see in the question, then it will be more clear. So as we discussed in forward interpolation formula, there we used to get delta y0, delta 2 y0, delta 3 y0 and so on. Those things were leading forward differences. Fine, no? Here we are interested in backward difference yn, backward difference 2 yn, backward difference 3 yn and so on. So these are called as leading backward differences. Fine. Okay, so now we'll see the question. So these two questions we are going to solve today. So very first question is what? The following table give the values of tan x. Fine. For the range is given to us and they are asking that find the value of tan 0.26. So this question is very important, and this question actually says us that what is the application of interpolation, that we are going to estimate the value at any unknown point, right, where the tabular form is given. That means the value of tan x is given at x equals 0.10. The value of tan x is given at x equals 0.15 and so on. So we are going to use Newton's backward interpolation formula to solve this question. And why we want to use Newton's backward interpolation formula? Because as we said that if the unknown point, right, what is given to us is near to the last value of x, so we will choose Newton's backward interpolation formula. That means if I'll give some name here, this is x0, x1, x2, x3, x4. So here last value of x is what? This is your x4. This is your 0.30. Fine, no? We have to estimate the value at 0.26. So it's better to use Newton's backward interpolation formula because 0.26 is near to 0.30. What we do, we just make one line and then we divide it into half, okay, and if the point lies in your previous half, then you go for Newton's forward interpolation formula. If the point lies into the second half, then you go for Newton's backward interpolation formula. Again I will say that you can use Newton's forward interpolation formula also in this question, but that is not recommended as the calculation will be very high and you will lose the accuracy. Okay, so better to use this method, that if the point is near to your last value of x, go for Newton's backward interpolation formula. Okay, so now we will be seeing that how to start this question. So we had discussed in last class that only two steps we have to follow. Fine. Step number 1 was what? In my step number 1 in forward interpolation formula, we were drawing forward difference table. In my backward interpolation formula, the very first step is what? To draw backward difference table. How to draw backward difference table? It is exactly same like how we were drawing forward difference table. Fine, no? That means what I have to write down? Right now I'm not sure that how many columns I will be having in my this table, but I'm 100% sure that I can write x column and I can write y column. Fine, no? So what will be there in my x column and y column? These two rows actually I'm writing in the column form. So 0.10, 0.15 and all these things I have written down in the column form. Fine. And similarly y values I have written down here. Okay, so in my backward difference table, very first thing I'm going to write is my first backward difference of y. Okay, so y is here. What I have to write down here? I'm going to subtract these two values. I'm going to write the answer here. That means 0.1511 minus 0.1003 is written down here. Fine. Similarly, these two values, that means 0.2027 minus 0.1511 is written down here. Similarly, these two differences I have written down here, and last two differences I have written down here. Okay, so and always write down the difference in between these two values, otherwise the table will be very confusing. Okay, so since you have written down here all those answers, so this is your first difference. Okay, and don't forget to write down upside down. If you will write down triangle like this, you are going to lose your marks in your backward difference table. Okay, fine. Now what I have to do, since I have done till here, but I can see that these values are not same. That means difference is still there. So I'm going to again find out the difference. That means the difference between 0.0516 minus 0.0508 is written down here. Similarly, 0.0526 minus 0.0516 is written down here. Similarly, these two differences written down here. And this will be called as second backward difference. Again, I will keep on moving because the differences are still there. The values, all values are not same. That means I'm going to find out the difference between, again, this is what, 0.0010 minus 0.0008 I have written down here. Similarly, these two differences written down here. This is nothing but backward difference. This is nothing but third backward difference of y. Okay, and then finally what you are going to do, you are going to find the difference between these two values. Okay, so here you are going to stop. This is nothing but your fourth backward difference. When we will stop adding more columns, there are two cases, right? One will be if suppose these two values were same. Okay, so that means here you were getting zeros, all zeros. So if all zeros you have got, then further you don't have to go, right? Because all other differences will be zero only, so you don't need to go anymore. Second case is if you have reached to any column where only single value is there. That means you don't have to find out any differences, right? Only single entry is there. So you have to stop here. So here you have not got the differences zero. That is also okay. But you have got single entry. So you have to stop. Fine. So this was my step number 1. Step number 2 is what? In my step number 2, I am going to write down the formula of Newton's backward interpolation. But Newton's backward interpolation formula demands leading backward differences. Fine, no? And to get leading backward differences, we actually build this backward interpolation table. What is leading backward differences? So they are the last entries of your difference table, of your difference column, right now. So these values are your leading backward differences. And how we denote it? We denote it with upside down triangle yn. Okay, and this is how much? This is upside down 2yn. This is your backward difference 3yn, and this is your backward difference 4yn. Okay, so you remember that when we were drawing forward difference table, we were interested in these first values, correct? No, first values, and even this one also. So that was your leading forward difference. But here be sure that you are going to choose the last values. So these places where students get confused in exams, so in backward difference table you have to choose the last values. Okay, fine. So now what we are going to do? Now the second step is what? Step number 2 is write down your backward interpolation formula. So in backward interpolation formula also be sure that you have done all these 3 changes in your forward, if you are referring your forward interpolation formula. Fine. So if you have written down the formula, then what is unknown to me? The unknown is my r. I know that r is real, but what is r? Right now, what the value is there? So for getting r, I am writing down x minus xn by h. In my forward difference table, the formula for r was your x minus x0 by h. It was there for your forward interpolation formula. Fine. Now in your backward interpolation formula, be sure that you are writing down the formula as x minus xn by h. Okay, so xn was what? Xn is my last value in my x column. This was your 0.30. So I have written down x. X is what? X is the point where I am interested in finding out the value of y. That means where they have asked in the question the value. So they had given us to find that what is tan 0.26. Fine, no. So this is my x here, because at this point I have to find yr. Fine, no. So x is my 0.26. Xn is last value in your x column, and h is what? H is difference between your different instances of x. x0, x1, x2 and xn. What are the differences are there? So you can see the difference between them is how much? 0.05. Right now 0.15 minus 0.10. Similarly 0.20 minus 0.15 and so on. So you will find that the difference will always be same among these all entries, and it is nothing but 0.05. Fine. So before choosing whether I have to use Newton's forward or Newton's backward or Newton's general interpolation formula, the very first step, as we discussed in last class, that very first step is what? I have to check that whether all those values are equidistant or not. If they are equidistant, then I don't have to use Newton's general interpolation formula, or we call it Newton's divided difference formula. So that means we came to know that this is my r. All those values are written down here, and then finally we are just going to substitute these values. So this is what we are interested in. Fine. And this is what? This is your yn, correct? No, this is your yn. What is your yn? The last entry in your y column. So written down this yn here, and then this was your r, and this is your first backward difference of yn, so you have written down here, and similarly you have just put the values there, and then finally you got the answer is 0.26602. So this is your answer of tan 0.26. Okay. So this is the second question. The area of a circle A corresponding to diameter D is given below. That means they have given you the tabular form. Fine. So D is the diameter and D is some independent variable, and area depends on D. That means area is nothing but function of D. Correct? Fine. So how we used to write down that y depends on function x. Similarly here area depends on d. Fine. So find the area corresponding to diameter 105 using an appropriate interpolation formula. So they don't give you the exact name of which interpolation formula you have to use. So here you have to decide that which interpolation formula I should choose. Fine. No. So to choose the interpolation formula, you are going to again check whether the differences between different instances of your d, right? So they are same or not, so whether they are equidistant or not. If they are not equidistant, then you are going to do Newton's divided difference formula, right? That will be seen in coming classes. So the difference between these two columns are exactly same. Fine. No? So that means you are going to use either Newton's forward or backward interpolation formula. Now the step number 2 is I am going to now check that the point what they have given to us, right? The point is near to my D naught, right? Or the point is near to my D4. So this is 105. 105 is near to 100, right? So that means I'm going to use Newton's backward interpolation formula. Again, this question is very good application of interpolation. That means interpolation in our day-to-day life also. Interpolation is very much useful to find the pattern of any unknown point where the points are not lying between any given range. Okay, the range is from 80 to 100, and right, and here you can see that how area depends on D. But what about 105, right? 105 actually lies beyond the range, and then still using interpolation formula you can actually estimate the value at 105. And since the point which is given to you is outside the range, this is called as extrapolation. Okay, we have discussed what is extrapolation and all those things. Fine. No, so generally interpolation actually includes extrapolation also. So they can ask question of extrapolation under your interpolation. So by looking at the table only, we understood that we are going to use Newton's backward interpolation formula. So how to start with? Again, we are going to use two steps. Fine. Now, what is my step number 1? Step number 1 is I'm going to draw backward difference table. Fine. Step number 2 is what? I'm going to write down the interpolation formula, backward interpolation formula, using the leading backward differences which I have got from my backward difference table. And then finally using calculator, I'll be getting the answer. Fine. So this is my step number 1. You know how to draw backward difference table. Fine. No. So they are your leading backward differences. For that only I have drawn backward difference table. So this is your delta yn, this is your delta 2yn, this is your delta 3yn, this is your delta 4yn. Okay, so these values I'm going to use in Newton's backward interpolation formula. Don't write down here upside delta. Fine. Okay, so now the step number 2 is here. Step number 2 is write down the Newton's backward interpolation formula. Here you have written down. So be sure that these changes you have made. Fine. So now what I'm going to do, I have to find what is R. R is real number for sure, but the formula for backward interpolation table is what? This is x minus xn by h. What is h? H is difference between different instances of my x. That means the difference is nothing but 5. Fine. No. So h is 5. X is the point at which I am interested in finding out the value of y. So this is 105. And then xn is the last entry of my x column. And then finally So I have got r as 1. Okay, so the r is 1, then this is r plus 1, this is r plus 2, and so on. And these values are nothing but backward difference yn, then backward difference 2yn, and so on. And finally, you have just calculated these values. So this way we calculate Newton's backward interpolation formula. And in next class, we are going to see the interpolation in groups. Okay. So if you find this class useful, please like and subscribe my channel. Thank you.